All right, round two. Let's try this again. So I'm going to go through some of the homework problems. I managed to do a couple of the homework problems and then completely forget that I was recording them. So rather than just having the solutions up here, let's just do it all over again. So this is a listing of our homework solutions. Note for the homework problems, they're a mixture of sine problems, cosine problems, and tangent problems because you have to be able to graph all three. And so let's take a look at our homework problem. Our number one problem says we are doing a problem dealing with sine of pi x minus 4. And the problem says in the instructions, we are supposed to identify the midline, the amplitude, the phase shift, and the period, which I will do over here. I will also make a listing of the values that are important over here while graphing one specific period. Now, since this is a sine function, make the following graph. Looking beautiful so far. And from here, I want to know my midline, where the center of this graph is, my amplitude, how far up and down it extends from the midline, my phase shift, how far it moves left to right, which for most of these problems they will not move left to right, and finally the period. Now, for this problem, let's take a look at each of these. The midline is based upon the value of d. In this specific problem, the value of d takes place at -4. This tells me that -4 up and down is where I'm going to put the middle of this graph. So I go to my picture, I go down 4, so I'm going to go 1, 2, 3, 4. I'm going to have to extend my graph a little bit. So down here at -4, it's going to go my midline. It's so pretty. Now, my amplitude is the value that extends up and down. So again, my midline is based upon the value of d, right here. My amplitude is the value that exists out front of the function. So if there's no value there, we assume that value is a 1. And so that tells me that I will go up 1 from the midline and down 1 from the midline. So up here at -3, I will put my amplitude going up. And down here at -5, I'll put my amplitude on the bottom side of it. And so remember, the sine function is going to bounce back and forth in between these two, creating our function. Let's talk phase shift. Phase shift is how far I move left to right. It is defined as c over b. In this case, my c value is 0. My v value is pi. 0 divided by pi is, of course, 0. Meaning this graph is not moved left or right. This tells me my first point takes place at -4, 0. Meaning I can start creating my table of x's and y's, starting at 0, -4. Now our period is defined as how much I shift up and down. How much it takes to go left or right. So the period is defined for sine as 2 pi over b. In this case, I'd plug in 2 pi over pi, which gives me a value of 2. This tells me my period for this function will start at 0 and go 2 to the right. So come up here. Let's call this 2. Now, remember, this is a sine function, which means that the last value of this function will end on the axis, on the midline, at the end of the period. So I should end this function at the value of 2 on the x, but still at -4 on the y. Now, 3 values are going to go in between this, representing my 3 points of interest. Now, since this is a sine function, they're the middle of those values, so between 0 and 2 is the value of 1. I'll have another point that is on the midline. So you end up having 3 points on the midline. That is always true of sine. And then, because it's a sine function, we'll have 1 point that goes above, halfway in between again. So again, at the point 1, we're at -4 again. But halfway in between, I'd have 1/2. Halfway between 0 and 1. And then halfway in between 1 and 2 is the point 3/2, or 1.5. And that will reach the lower value, which will be down here, creating my beautiful sine function, which starts on the midline, comes back to the midline after hitting the amplitude, comes down to the amplitude again, and goes back to the midline, creating one smooth and beautiful arc. These 5 values, again, come from the period, which defines the ending place, the phase shift, which defines the starting place, and then halfway in between those two, so between 0 and 2 is 1. That gives my first point of interest. And then between 1 and 0 gives my second. Between 1 and 2 gives my third, giving me a total of 5 points of interest. 1/2 would go here at -3. And then at 1.5 would go the value of -5. At this point, I can now open a graphing utility to check my work. Always check your work. Very helpful here. I'm going to go to Desmos. I'm going to type in my function, which in this case is the sine function. So sine of pi x minus 4. Let's take a look if our values were correct from this table. This tells me it should start at 0, -4. So if I click right here, I can see that point very clearly, 0, -4. Very nice. And I should have a maximum at 1/2, or 0.5, -3. It looks like it's beautifully distributed there onto my picture. And then I should have a minimum at 1.5, -5. Again, all those points match up. And I can check the other two just by typing in the y value, which is y is equal to -4. And I can see that the other two values are clearly 1, -4, which I have right there, and 2, -4, which I have right there. Again, these 4 pieces, which are required for your homework problems, help to define the function in terms of how they fit together. So having each of those pieces is really, really important. Once I've got my function, make sure it looks correct, make sure it matches the picture in the function, and note again, we're only doing one period, so we're only really focusing upon just one of these, like this. And so you can see, again, 0, -4, 1/2, -3, 1, -4, 1.5, -5, and 2, -4. Matches perfectly. One full period with the 5 points of interest and all 4 components from the problem recognized. All right. Look at problem 2. When you're doing these problems, some helpful tips and tricks. Always look ahead. If you can see something in the problem that looks important, you should probably be planning for it in the problem itself. For number 2, I have the function y is equal to -2 cosine of 3x. All right, I can see it's a cosine function. This tells me some things about how I need to do all of my components of the amplitude, midline, phase shift, and period. It also tells me how I want to start drawing my graph. Because remember, cosine typically starts on the origin. So I'm going to start right there. There's my beautiful graph. Okay, and I want to define the following values: midline, amplitude, phase shift, and period. So let's take them one at a time. So let's start with midline, as we did before. So the midline, again, is based upon the d value. In this case, there is no d value. The d value is 0, which tells me that for this problem, I need to be doing it on the x-axis. Again, if there is no value of d, we assume it's going to be on the axis, like so. You can just barely make out the pink there if you look real close. Okay, next, amplitude. How far we go up or down. So the amplitude is the absolute value of our a, which in this case our a function is -2, so then my amplitude would be at 2. This tells me I need to go up 2 and down 2 from this midline. So I need to take this function and go up to 1, 2, there's +2, and down to 1, 2, there's -2. And again, I make my midline to the best of my ability. So again, my midline should be halfway in between my amplitudes. So there it is. I got the x-axis, 2 above, 2 below. Good. All right, next. Phase shift, how far it moves left to right. The phase shift is defined as c over b. In this problem, my c value is, again, 0. My b value is 3. 0 divided by 3 is 0. This tells me it does not move left or right, which tells me that my first point needs to be on the amplitude. Remember, this is a cosine function. Cosine functions always start on the amplitude. But what's important to note here is this negative value out front. Because it is a negative 2, this tells me that rather than starting on the top amplitude, it's going to start on the bottom amplitude, which means that my first dot is going to go right there. So pretty. Now, my period, how far we need to go left to right, is 2 pi over b. In this case, this would be 2 pi over 3, which this tells me how far I need to go to the right to finish. So my first one is at 0, the phase shift, and I end 2 pi over 3 later. So I'm going to put that down here at 2 pi over 3. Excellent. Now, it's important to remember, cosine starts on the amplitude and ends on the same amplitude. So if my number is 2 pi over 3, that means I should have my second dot all the way down there. On the amplitude, in this case on the negative amplitude, because it's a negative 2. And so I've got my 2 points. Let's start making my table. I know my starting value is at 0, negative 2. My ending value is at 2 pi over 3, negative 2, which means I now have 3 points of interest along the way. At the halfway point, I should have another point of interest, so halfway between these two, I should have another point of interest. Because this is a cosine, that halfway point is on the opposite amplitude. So, halfway in between 0 and 2 pi over 3 is the value of pi over 3. So right here should be pi over 3. So that's halfway in between these two. And then on the opposite amplitude, I should have another dot right there. Picture perfect. Next, what I want to do is determine my other values. So that should be at pi over 3 and at 2. Now, halfway in between each of these, so right here in my picture and right there in my picture, is going to go another point of interest. Now, for cosine, those points of interest occur on the midline. So that means that I should have a dot right there. Again, halfway in between the pi over 3 and the 0, and a dot right there. Remember, if you have trouble finding these values, what you can do is use the average formula, which will tell you to take those values and add them together and determine the value from that. What am I doing? Average. So I can take pi over 3 plus 0, which gives me pi over 3 divided by 2, and end up with pi over 6. That is at the halfway mark. That's pi over 6, 0, because it's on the x-axis. And then for this one, I plug in pi over 3 and 2 pi over 3. I end up with pi over 2. I actually end up with 3 pi over 6, which reduces to pi over 2. But again, it's all about the halfway in between, which means visually it's easier to see this function this way than it is to do it any other way. So I've got my 5 points of interest, 1, 2, 3, 4, 5. I've got my 4 components labeled out as I need them. I'm now going to connect my dots and make my graph. Looking good. Looks beautiful. And now I go to Desmos to check my work. So I have my new function. This time it is cosine. Oh, I have a negative 2 out front, so I'm going to go negative 2 cosine of 3x. And so I go back to my home screen. Looking good. I go to one full period. The first full period, which appears to be right here. Looks great. Okay, let's check my values. At 0, negative 2, I have a starting place. Perfectly matching. At an ending place, at 2 pi over 3, at negative 2 again. Perfect. My top value is at pi over 3. Looks good. And then I have two values, one at pi over 6 and one at pi over 2. This problem is good. So, we've checked our work on our first two problems. They both turned out pretty good. Let's go ahead and look at problem number 3. Alright, problem number 3 says y equals 4 tangent of x plus 2. And so I'm going to go through the process. Tangent is a little bit different than sine and cosine. And so let's point out as we go through this problem how it's a little bit different. First of all, the big difference is that the graph looks a little different visually. Remember, tangent is centered on the origin in most cases unless there's a phase shift. And so while I typically look at the right-hand side in order to draw sine and cosine, I look at the center to draw the tangent function. And again, I'm going to look at those four values. We have the midline, amplitude, phase shift, and the period. And just to preempt this, I'm going to go ahead and start looking at my table here. Beautiful. Okay, let's do it. For this function, let's identify all of our components and start graphing this thing. First things first, midline. So I can see the midline is always based upon the value of d. In this case, the value of d is 2. This tells me that I'll be centering my graph on the y-axis at 2. So we're going to go up 2, 1, 2. So up here at 2. I'm going to create my midline. And again, I could count by weird values if I wanted to. I want to learn from my mistakes. My first one, because I graphed such small numbers, like they ended up really tight together, making it kind of hard to see. So this time, spreading it out, I'd use more paper, but it's easier to see and easier to do. So my amplitude comes next. My amplitude is based upon the value of the absolute value of A, which in this case, my absolute value of A is a value of 4. This tells me I need to go up 4 from 2 and down 4 from 2 to make my graph, which means I need a bigger graph. Let's do it. I'm going to extend it up a little bit. I think downwards I'm actually okay. So let's do it. So there's 2, which will make us 3, 4, 5, 6. Which again is up 4 from the midline. And then I go down 4. So 1, 2, 3, 4 down. Here at -2 goes my other amplitude. So again, trying to learn from my mistakes. The first one seemed too cluttered and made it harder to do, so now I'm doing them really spread out. But in so doing, like, you run this risk of having that piece really not fit very well. Okay, next, we have 4 tangent of x plus 2. Let's identify our phase shift. The phase shift is based upon the value of c over b. In this case, my c over b, my value of c is 0, my value of b is a 1, which means my phase shift is 0. Now, tangent, its first dot is on the phase shift, that's the x value, and then on the midline, that's its y value. And so this tells me that my first dot needs to go right there. Big dot. Easy to see. Alright, now I do my period. My period is based upon, for tangent, it is pi over b. This tells me that in this case my period is pi over 1, which is just pi. Now remember, it is split for tangent. The asymptote causes this thing to split halfway to the left and halfway to the right, because again, it's centered on the origin. And so half this number needs to go to the left, and half this number needs to go to the right. So half of pi would put us at -pi over 2. The other half of pi would put it at +pi over 2. Again, this is where the asymptotes go. It's based upon the period, and you cut that period in half to determine where the two new values are going to be. This tells me that to the left, I need to go -pi over 2. And to the right, I need to go +pi over 2. And these are where the asymptotes are going to be. So I have my first dot here at +2, 0, +2, didn't move left or right. And then at -pi over 2, I have an asymptote. And at +pi over 2, I have an asymptote. Looking good so far. Now, let's talk our next dot. Our next dot needs to go halfway in between these two. So I have my left-hand boundary here. My right-hand boundary there. Okay, we're going to draw our function inside this box. So halfway in between and halfway in between is going to go our next 2 points of interest. So our first and last are the asymptotes. Our middle one is based upon the phase shift. All right, halfway in between. So this would be at negative pi over 4. Okay, I could use the halfway in between formula, the midpoint formula. This tells me that this will be at pi over 4, negative. And for tangent, remember tangent usually goes down to the asymptote, then to the mid, then up to the asymptote. So halfway in between, I go up to the asymptote to determine the other functional value. Now, this is going to be kind of wonky because this function does not fit very well. Again, this will be at positive pi over 4. So at negative pi over 2, I am undefined. Negative pi over 4, I am at negative 2. At 0, I'm at positive 2. At positive pi over 4, I am at 6. Okay, let's do it. From there, I graph my points. Again, you always want to level off as you get to this midpoint. This one's just going to extend down here towards the asymptote. And on this side, we have it come up through that point, and then extending up to the other asymptote. Again, this asymptote will continue upwards, same as this little line right there. And based upon that, let's see what Desmos says. I put Desmos. I type my new function, which is 4 tangent of x plus 2. Okay. Go back to home. Alright, you can clearly see it. This one's pretty stretched out. So I'm going to zoom in on one factor here. So, easiest point is that middle one, 0, 2. That's clearly right there. Now, let's see if I can find some other ones. At negative pi over 2, I should have an asymptote. So type in negative pi over 2. And I can clearly see that this function, this red line here, is approaching the green line, but never quite getting there. At positive pi over 2, I should have the same thing on the other side. Yep, looks like it. I'm approaching that green line, but not quite getting there. And then at negative pi over 4, let's look at positive pi over 4, I should be at 6. And then at negative pi over 4, I'm down here at negative 2. Look at that. Everything seems to fit together perfectly. I'm going to go through 3 more problems, and then I'm going to call it. Here we go. That's awful. That's going to confuse me. Fresh page. Look at that. Pretty. Alright, number 4. Let's go back to here. Number 4 says y is equal to sine of 2x plus 1. Alright. So again, it's a sine function, so I'm going to modify this a little bit. There we go. Okay, I want the midline, the phase shift, the amplitude, and, oh my gosh, I can't remember where, look at that, and the period. Okay, big differences between the phase shift, the period for sine and cosine versus tangent. Remember, the period for sine and cosine is based upon 2 pi over b, whereas for tangent is based upon pi over b. The other weird thing is that tangent is centered, whereas sine and cosine are offset to one side, which is a little different. So, let's try it out. First things first. Midline. Midline is based upon the d value. In this case, my d value is at positive 1. This tells me that when I go up 1, it's going to be where the center of this graph is going to be. So come up here to 1. Looking good. I'll do my amplitude next. Amplitude is based upon the value of a, the absolute value of a. In fact, in this case, there is no number out front, so we assume that number is a 1, which tells me I need to go up 1 and down 1 from my midline. So down 1 is easy. That's the axis. Let me get my blue line, there we go. And the up one will be up here at 2. Alright. Phase shift is the value left or right. It depends on C. In this case, my C value over B. Again, for all these, it will likely be 0. Because again, the phase shift is the hardest part, and we're going to do that in class. So this tells me that my first dot needs to go in a very specific spot. Since it is the sine function, your starting place is always on the phase shift, on the midline. So this tells me that my first dot goes right here. So in this case, my chart of x's and y's, my first dot would go at 0, 1. My next dot goes at the end of the period. Now remember, the period is how far from the phase shift it ends. So in this case, my period is defined as 2 pi over the b value, again, because it's a sine function. So 2 pi, in this case, over 2, which tells me that my period is going to be a pi value. So that means that pi to the right of the phase shift is going to go my ending point. So down here, all the way at the end, I'm going to call this pi. This is where this function is going to end. And again, sine always ends 1 period later on the midline. Looking good. So I got my 2 points. Now, again, in the center of those two, since this is a sine function, we'll go another point on the midline. So the center between 0 and pi is pi over 2. So at pi over 2, I'm going to be back at 1 again. I'm running out of spacing here, so I'm going to change it up a little bit. Let's see. Halfway in between these two, which would be at pi over 4 and 3 pi over 4. Again, you can plug into the formula to determine those. So at pi over 4 and 3 pi over 4. So at pi over 4, the sine function is positive, so it will go up to the amplitude. So up to there. Choose my dot goes right here. And then at 3 pi over 4, the second point of interest, it'll go down the amplitude. So my amplitude, remember, is down here on the axis. So it'll go right there, halfway in between these 2 points. So the top one will be at 2, the bottom one will be at 0. Last thing, I connect my dots, making sure it looks like the sine function. It always will try to level off when going through the max and the min. So go in here, try to level off, and then come back up to the dot. So these middle dots are transitionary. They're just there to determine how to get there. Whereas the top and bottoms are the curves, the smoothness that we're looking for. And so there's my function. I go back to Desmos. Let's type it in. My function was sine of 2x plus 1. Okay. Clearly starts at 0, 1. It's going to end, if you can't tell, this will end at, yep, that's 3.141. That's pi. So that's definitely over there at 1. It has a minimum at 3 pi over 4, a maximum at pi over 4 and 2. And don't forget, I can always use the function y is equal to 1, the midline, to see all my dots. There's 1, 2, 3, and then also our minimums and maximums. Beautiful. Alright, let's do 2 more. Next one says, just 5. Number 5 says cosine of pi x minus 2. So looking ahead, I see it's a cosine function, so that tells me I'm going to go up or down, like so. Now again, just looking ahead, I see I have a negative 2 here, which means it's going to go down some. So I'm going to actually get a little head start here. I'm going to take a look, and I'm actually going to draw it all the way down here. Again, you have the advantage when you're making your own graphs of these. You don't have to follow the same picture every time. Customize your picture to match these components. So I have the midline, the amplitude, the phase shift, and the period. Okay. And then again, I'm going to make a table with X and Y. Let's do it. Starting value on the midline. Midline takes place for D at -2. This one's me. I need to go down 2 on my graph. Down 1, down 2 to -2. And there's my midline. Oh, so pretty. Okay. Now, it says we need to go to the amplitude next. Amplitude is how far we go up or down from the midline. That is my A value. If there isn't a number out front, a coefficient in front, we assume that coefficient is a 1. So this means I need to go up 1. So up here to -1. And down 1. So down here to -3. Looking good. Now I do my phase shift, which again is C over B. So my C value is 0. My B value is pi. So 0 over pi, which is just 0. This tells me that my first dot takes place at, so it'll be its cosine function, right? Cosine starts on the upper amplitude unless it's negative, which means it'll go right there on the phase shift, 0. Oh, I'm putting it all the way down there. I'm silly. On the phase shift, 0. On the amplitude, -1. Now, next, it needs to go down 1 period. Now, 1 period is based upon the formula 2 pi over b. So that'll be 2 pi over pi. And the pi's cancel, leaving just 2. This tells me that my ending spot will be 2 units down. Now I'm going to give myself some space to work with. So I'm going to call this 1 and this 2. Again, you're the one drawing the graph. You're the one calling the shots here. So 1 full period later, it is going to be, since it is, again, cosine, always starts high, dips down, and then comes back up and ends high. It always has this U shape to it. So I know it's starting on -1. I know it's going to dip down and come back up, which means that my finishing point should be right here at 2, -1. So again, it is 1 period later, so it starts at 0, ends at 2. It is on the upper amplitude, because again, it's cosine. It starts high, ends high. And then what happens halfway in between? Well, halfway in between, here at 1, I should be on the lower amplitude, so at 1, -3. And halfway between each of those, so at 1/2 and 1.5, or 3/2, so 1/2, I should be in my midline, so right there, which is at -2. And halfway between, it should be right there. The cosine always creates a V shape or an A shape, depending on whether it's right side up or upside down. But remember, it's the look of cosine that has to be right. It has to look like the cosine function. So there are my 5 dots, and then 1.5 or 3/2, it would be again at -2. But let's make it look like cosine. So cosine, again, it starts level, curves down through the dot, levels off as it reaches the bottom, comes back through the dot, levels off as it reaches the next dot. So it has this nice bell shape is what it's called. Man, that's pretty. All right, Desmos, speak to me your wisdom. Cosine of pi x minus 2. Okay. Starts 0, -1. Yay. Ends 2, -1. Yay. Halfway in between, I'm at 1, -3. And then I can't really tell those other values, so I'm going to type in my midline, which is y is equal to -2. And see that, yes, in fact, at 1/2, it is at -2, and at 1.5, it is at -2. Both values we found manually using our picture. So there we go. All right, last one. I'm going to skip to number 9. The reason being is I have not done a phase shift one with tangent. I don't think it was. No, I didn't. Okay, so yeah, let's go to number 9. So number 9 says 4 tangent of 2x. Alright, let's do it. So again, I'm going to modify my picture to graph this correctly. So again, tangent is centered. I noticed that there's no d value, so it's not going to move it up or down any. So I can center it very nicely here. Alright, looking good. You know, with that 4, that's going to make it pretty large. So, you know what? Maybe I should make it pretty large. Let's do it. Big old graph here. Again, you could get away with it by just counting by a different value, but I'm going to try to count by ones on my picture. And let's see what happens. So, let me get my x and y's. Again, there's going to be 5 of them. 5 points of interest. And let's talk midline, amplitude, phase shift, and period. Alright, let's do it. Starting with midline. There is no value for d, which tells me that it will be on the axis. You can see my, just barely, that beautiful pink line going across. This is where the center of my graph is going to be. My amplitude, it says, is 4. Remember, the amplitude is the absolute value of A. So the absolute value of 4, which is, of course, 4. So that means I need to go up 4. So 1, 2, 3, up 4. And down 4. 1, 2, 3, 4 to negative 4 to create my next lines. Okay, looks pretty. So I've got my midline at 0, my amplitude at 4 above and 4 below. Let's talk phase shift. C over B. So C over B, in this case that'd be 0 over 2. The 0 over 2, which is of course 0. Now, where's my dot go? 0 tells me my x value. So my x value is at 0. My y value is on the midline. Because remember, tangent is centered on the midline. So that means my first dot goes right there. And it's in fact on the origin. Okay, let's do period now. The period, remember, is pi over b. This means that my value is at pi over 2. That's great. Remember, this period is going to be split, because it is a tangent function, into 2 asymptotes. One to the left and one to the right, covering a total of pi over 2. So to get this asymptote in the right spot, one of the best ways you can do it is to cut this number in half again. So you end up with pi over 4 on each side. This tells me that to the left I need to go to negative pi over 4. And to the right I need to go to positive pi over 4. Again, in total, the distance is pi over 2. Because the distance between negative pi over 4 and positive pi over 4 is pi over 2. Add those two values together, and you'll find the total distance by plugging in the distance formula. However, tangent is split around the period. So I have to split the period up to determine the actual value. There we go. So this tells you that my asymptotes will be at negative pi over 4, will be an asymptote, and at positive pi over 4 will be an asymptote. Alright, looking good. Now, halfway in between needs to go something interesting. So, halfway between negative pi over 4 and 0 is the point negative pi over 8. Again, you can plug in the formula to find that, or just look at it visually. So here at pi over 8, I should be, since remember it's tangent, it's a positive tangent, so that means it's going to go down to the asymptote, so right there. And on this side, same thing, between 0 and pi over 4 is the value of positive pi over 8. But remember, it's a positive tangent, so it's going to go up to the asymptote. Which would give me the following points. So this first one would be at -4, and this would be at +4. Now I graph. So again, tangent starts out kind of level, then it falls through the point, and then it keeps falling towards the asymptote. Beautiful. And then it starts level, rises up through the dot, and then continues up to the asymptote. Looks pretty darn good. All right. Desmos, check my work. How did I do? So my function is 4 tangent of 2x. Okay, this is looking interesting. So let's see. I'm going to have to keep this kind of weird. All right. So let's see what's happening at some of these values. So I'm going to first check my asymptotes, which are at -pi/4 and +pi/4. So I type in x, because those are my x values that are -pi/4. So x equals -pi/4. Oh, that's 3. 4. I can clearly see this. I hate the red line. So I can clearly see that this, the red line of the function versus the red line of the graph, is clearly approaching and yet bounded. On the positive side, same thing. It clearly sits right on the right hand side of this function, always to the right of it, never blocking it. Okay, now let's look at what happens at -pi/8 and +pi/8. So at -pi/8, we can see right here, we have the value of 4, exactly as we predicted. And then at -pi/8, we have a value of -4, again, exactly as predicted. And of course, lest we ever forget, the 0.00. So, must be good. That's how you do 4 of the homework problems. So that's 4 out of the 6 done. I'll post solutions for the other ones when I get a chance. That'll be it. Hope you guys have a good rest of the day. Enjoy your time off. And I will see you guys tomorrow.